Question 3, we've got our selection question. Is it a geometric? Is it a negative binomial? Is it a binomial? All of that. So we'll have a read through of it. And they're taking blue counters, and the probability of a blue counter is 1/5. And we're going until we select a blue one. So we are talking about a geometric with a probability of 1/5. And in part A, so Suzanne has a go, then John, then Suzanne, then John, then Suzanne, then John. And then we want Suzanne to win on her fourth go, which is that one there, isn't it? 1, 2, 3, 4. So that is the 7th go overall. So we want the probability that x equals 7 in the geometric. So we might as well use our geometric distribution one as we've got it. Geometric, we want it equal to 7 with a probability of 0.2, and that gives us 0.0524. Checking the extra digit, 5242, so absolutely fine with that one there. And just thinking about it, let's just make sure logically, so basically what we're having here is fail, 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 fail. So it's 0.8 to the power of 6 of them times by 0.2. And of course we get the same answer there, but it's nice to check logically as well. Part B. Find the probability that a blue counter is first selected on or after John's third selection. On or after John's third selection is that one there, isn't it? So that's the probability that x is greater than or equal to 6. So again, we might as well just go into our distribution ones and go for geometric, and we'll change that to a 6, and we'll change that to a greater than or equal to, and so that's 0.3276 or 328, rounding that properly. Making sense of that, of course, that means that really these 1, 2, 3, 4, 5 were all failures, and so we can just check that again. 0.8 to the power of 5, they were all failures, and look, we get exactly the same thing there. Part C, we need to remember the mean and the mean formula. So from the formula book, the mean is 1 over p, so 1 over a fifth is equal to 5, and the variance of x is q over p squared, so that's 0.8 over 0.2 squared. I'll just work that out now. 0.8 over 0.2 squared, and that's 20. But because we want the standard deviation, so the standard deviation is root 20, and root 20 is 4.472. So the last part must be a bit of more complicated thinking, is it? Find the probability that Suzanne wins the game. Okay, right, I think I'll just go back to the little row of them there then. Right, Suzanne can win the game on her first go, which is 1/5. Or she can win it on her second go. Now her second go is that one there, so it's fail, fail, win. So that is 4/5 squared, and then she wins. Or she can win it on her third go, which is 4 failures, fail, 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 and then win. Yeah, and then win. And then I think we can spot the pattern of these now then. So I think the next one would then be 4/5 to the 6 times by 1/5. And that, of course, is the probability we had there in the 7th one there. Right, this looks like a geometric progression. The first term here is 1/5, and what do we times them by each time is 4/5 squared, so 16 over 25. And this is a sum to infinity, so a over 1 minus r So the probability that Suzanne wins, it's got to be more than a half, hasn't it? I think because she had the first go. So 0.555. That's 5/9, isn't it? Yeah, just 5/9. And that makes a reasonable sense, doesn't it? She had the first go. She's more likely to win. So that's a nice question 3 as well. Nothing too complicated.